Bismillah ar-Rahman ar-Rahim. This is a fourth class on a topic of linear momentum and last class on it. And this is a question I have given June 2020, 42 variant. All of you, please take some time. This is a 10-mark question. So I'll give you 10 minutes even for this question. Okay. So if you do one thing, try this question first yourself, okay? And I'm going to stop recording, and then I will discuss one doubt in the previous homework, question number 4. I will discuss inshallah after this question, okay? And but for a while, first part I think very easy, not very tough, inshallah for you. And part 2 I believe is easy, inshallah, but part show this another collision of AB. You know how to prove it? This one, if we prove that velocity of A is bigger than velocity of B, if we prove it, for example, A speed is 10, B speed is 8. Just example I said. Okay, you will find V from here, and after collision A speed you have it. We can guess from here that there is a after there's another collision comes that anyway. And after that you will find the speed of that whole system because it's coilless. And after finding this, you will go what? Loss in kinetic energy, start from beginning of the whole. So take your time. I'm going to stop recording. First you try, then I'll do this question, inshallah, myself. Bismillah ar-Rahman ar-Rahim. Yes, let start student the solution of course I have given to you. And now I'm starting this solution. Bismillah ar-Rahman ar-Rahim. Small, smooth A and B, two spheres, equal radii, and mass 4 and 2 kilogram. A mass 4 to B mass 2 kilogram, and lie on a smooth table or plane. Initially B at rest, and A is moving towards B speed of 10. Okay. After that sphere collide A, continue to move the same direction, but in a half speed of B. So let's start. Bismillah ar-Rahman ar-Rahim. Okay. I take some diagram here. Okay. This diagram, and you know, this full chapter of the linear momentum, if you do without diagram, really very hard. Very hard. Chance of mistake increases. So as a teacher, I suggest you see every question I make diagram. So that is why you have to do the same way. This is before collision, and this is after collision. If you don't write after, before, no issue, but diagram is good to make. All right, mass, it is a particle A, this particle B, A, B, and mass of A is 4, and B is 2, 4, 2. Initially, this particle U1 speed is given by him is 10, and U2 is 0 because it's rest. Look, A is moving towards B speed of 10. I wrote 10. Okay. After the sphere, this continue to move in the same direction, but a speed of half. I repeat, A continues to move same direction with speed of half of V. So let's say V velocity is X. So this velocity become half X, because he said have a speed of B. So I think this part is clear. And formula is M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Now mass into velocity 10 into 4. So it's become 40. Okay, this 0 into 2, 0. So half X into 4. This 2 half cancelled 4. We got a 2X directly. X times 2, I got 2X. So finally I get a 4X, and from here I get a 40. 4 divides, I get a 10. So it means 10 is a value of the V of B. So we can say the velocity of B after collision becomes 10 meter per second. Okay, but although he's not asking for A, but I think we need later on. So this 10, I'm going to plug in it here. I got velocity of A become half, because 10 divided by 2, half meter per second. And he was asking to get V only, velocity of B part only, but I found both. Okay, this part is very, very clear. Part number 2, a third small smooth sphere C with a mass 1 kilogram with the same radii as like a B. is at a rest, and okay, and B now collides with the C. All right, first AB collide with the B, and now B with the C. After this collision, B continue to move the same direction with a 1/3 of speed of C. So I will make this diagram here. Yeah, I believe inshallah you will understand how I do this question. And diagram is important. As said before, this is a B, C, B, and C. Speed, the mass of B is what? Let me check. Mass of B is 2 kilograms. So 2 kilograms, 2. And C is 1 kilogram and 1 kilogram. And as you know, this is our final speed after collision of B is 10, which becomes starting speed at this level. So U1, I'm writing 10 here. This is a starting speed, same like, because naturally when B will hit B last speed is B is 10, and the same speed it will hit C. So that is why this I'm taking at a starting speed. And U2 is 0. Reason I know that C is at rest. Okay, after that, he is saying what? So that B will move the same direction. So B is going first this direction, and B will go with the same direction. 100% C will move this way. And he mentioned that the speed of what is that? 1/3 of C. It means B will go in the same direction with 1/3 of speed of C. Let's say speed of C is Y. So V1 is 100% 1/3 of Y. And I believe it's clear. This is before collision, and that is after collision. Okay, but hold on. What is my target? Naturally, I will find the unknown speeds after collision, but show that there is another collision between A, B. Okay, I will discuss. Let's first of all find the speeds. So formula you are familiar, alhamdulillah, M1 U1 plus M2 U2 is equals to M1 V1 and plus M2 V2. So mass into, so 10 into 2, I get 20, 0 into 1, I get 0, 1/3 of 2, so 2 over 3 times 2y, and y into 1, we get a y here. Alhamdulillah Rabbil Alameen. You take LCM here, 3 LCM and 2y copy. This 3 multiply with a y, I get 3y. Ultimately, I get a 5y over 3 equals to 20. So 5 goes down, I get 4, and 3 multiplied 3, 4 is 12. So alhamdulillah Rabbil Alameen, 12. So it means velocity of the C is coming from here is what I'm writing now finally. So velocity of C particle is 12 meter per second. If I plug in this 12 here, so 3 into 4, 12. So velocity of the B particle is a 4 meter per second. But student, this is not my answer. My answer is that, what is the velocity after collision of A particle? 5. And what is velocity after collision B particles? 4. Write a statement as after collision, velocity of A is 5 meter per second. And after collision, velocity of B is a 4 meter per second. It is 100% clear. Listen, students. If A is here, B is here, C is here, A, B, C. Okay, first A hit the B and B hit the C, but A is still going on, and you know it very well. After A hits, okay. So speed of A is very clear. It is a 5 meter is going right side. And B after collision is going with their 4 meter per second. But there's no friction. Read the statement, please. He says smooth plane. So when friction is not there, 100% speed of A and B will not change, and they will go on same. Ultimately, because A speed is bigger than speed of B, so ultimately it will approach and hit. So it means there is another collision is there. I can say that. Hence, I can say that as velocity of A is bigger than velocity of B. So there is an other collision between A particle and a B particle, which is proved because he said that. Prove it. So alhamdulillah Rabbil Alameen, we have done it. And now I'm going to do part number last. He said if there's a collision, so fine. So A and B coalesce. Okay, it means this. So before, again, I discuss AB once again. Again, I'm going to discuss AB once again. But this time, what's condition? A and B will be combined and they will go together as a one particle. And as a one particle, you know it very well. What I'm saying, A particle and B particle. I think A and B are 4 and 2 kilogram. Yeah, A4, B2. Okay, 4 and 2. So 4 and 2 is a 4 kilogram, 2 kilogram, 4 plus 2 gives us 6 kilogram. This is a 6 kilogram altogether. Okay, so A is moving with speed of 5, you know it very well, and B is moving speed of 4. It is a very clear, and both are going right side, and naturally system will go right side with a combined velocity V. Okay, and now you know this is before collision and that is after collision. Is a very clear approach, and formula is very clear: m1 u1 plus m2 v u2. And I'm not writing here M1V. I'm writing here simple M1V plus M2V. Oh, no. Why, sir? Because you can ask me, because final velocity is same. Okay, now 5 into 4, I get a 20. And 4 into 2, I get a 8. And 6 and into V, because there's a if addition of the both, 6 plus 2, 4 plus 2, 6. So I get a 6V. And now this 28 and 6 go under it. So 28 by 6. If we type in calculator or do it simplify, it is coming with us 14 by 3. 14 by 3, hold on, right again. 14 by 3 meter per second combines. You can say AB combined, okay? The velocity of AB combined. But what he asking for? Total loss in kinetic energy in a system due to the 3 collisions. So it means at a starting stage, we needed to find. Now he's asking to find loss of total kinetic of the whole system. It means all 3 collisions. Collision number 1 is this, you know it very well. Okay, so collision number 2 is here, and collision number 3 is here. So actually, starting, this is called first, before the first collision. So the total kinetic energy of the before collision or the first collision I can talk about. So this is 0, so no kinetic energy, but here we have 4 and 10. So let's try to find it, initial kinetic energy of the system. So initial kinetic energy of the system. So naturally, we can say half mv square. The mass of the A particle is 4 mv, and half m, and v is what? Let's see again. Speed of the starting stage of A is 10. So that is why I have mv square. And this is cancelled. 2 ones are 2, 2s are 4, and 100 into 2, 200. So 200 joules is a initial kinetic energy. Okay, now I talk about final kinetic energy of the whole system. Actually, we have 2 energies. One is kinetic energy of C particle, and one is kinetic energy of combined AB particle. Okay, because the reason is very clear. Some student can ask me, sir, why you don't take this energy also? No, because collectively after the loss of the all together, this AB, the B is collectively include here. So that is why I will not include. Only C is separate. What is C? A final velocity, mass is 1, speed is 12. So I will take that as well. So half m v square, and combined AB is half m is what? 6. How 6? 4 plus 2, 6. So 6, and velocity is 14 by 3, and 14 by 3 square. And if you type this in calculator, let me check. Half 12 square and plus 1/2 into 6. Okay, this is coming 412 by 3 joules. So now loss in kinetic energy of all system together. So this is a bigger, this is smaller. So I'm writing 200 minus 412 over 3, and give me final answer 188 by 3. 188 by 3, or in decimal 62.7. 62.7 joules kinetic energy loss of the whole system. I hope so this part is clear, and after this one we'll go for doubt of question number 4, the previous homework. Yes, student, it was a homework, and some students have confusion, especially they are getting a problem in this part B, especially. So they have a confusion here. So let's start to solve this one. So this is a June 2021 41 variant question number 3. Bismillah ar-Rahman ar-Rahim. Three particle PQR given here, very clear pass. Mass of P is this one, Q is this one, R is this one. Okay, in the beginning or are at rest position. Okay, so I will make it a diagram, and I always make diagram like this, so it helps us to solve a question. And data writing is easy in this option. He says P is thrown towards Q speed of 5. So P and Q, I repeat again, P and Q. Okay, P mass 0.1, Q mass 0.2, 0.1, 0.2. Okay, and this one thrown with a speed of 5, U2 is 0 because it rests. And he's saying after P rebounds with speed of 1, it means it will come back with speed of 1. So U2 is equals to 1. And Q will naturally will go away, and that is, sorry, there's a V1. Sorry, there's a V1. So V1 is here, and V2 I need to find. So find a speed after collision of P. So naturally, this is a before collision, and that is after collision. So let's try to find M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. So 5 into 0.1, I got a 0.5. 0 into this, I got a 0. 1 into that, but make sure observers I is here. Okay, and you know it very well. When it's going away, velocity positive, coming backward, negative. It's coming backwards, so velocity negative. So 0.1 into negative 1. So 0.1 times 2, negative 1. And this into that, so 0.2 times 2v. This is a negative 0.1 goes here, 0.5 plus 0.1 and 0.2v. I got 0.6, 0.2v. So V becomes 3 meter per second. Alhamdulillah Rabbil Alameen. After collision, the particle speed Q is 3 meter per second. Alhamdulillah, very easy, nothing hard at all. A problem is coming in next part. So now he says Q collide with R. Q collides with R. Immediately after collision, R begins to move with speed of V. So again, I will make a diagram here. It is a very important diagram. I will make it again, but here especially one part is very critical, so that you must understand. Okay, this is before collision, and that is after collision. Okay, so one only point important. He said now Q collide with R. So Q, R, Q, R. Okay, Q mass and R 0.2, 0.5. Make sure R is a bigger mass, even more than double than Q. Okay, come back. Immediately after collision, Q and R begins to move with speed of V. So it will move with speed of V2 is actually V. So there's no subsequent collision between P, Q. Hold on. This is a final velocity after collision of Q particle will become starting velocity at of Q. But R is at rest, so U2 was 0. So only one thing left behind, students. What is the left behind? What is velocity of Q? That is the most important part here. And many students stuck here because he did not give you this. I think this kind of only one question up till now came in exam papers. He did not mention the speed of that, but we have a small guess, small idea available in my question. Look at here. There's no subsequent collision between P and Q. This is a critical point here. Repeat. Look at here. Before I tell you, P is initially moving speed of 5. But after collision, it is going backward with a -1. Repeat my words again, and it means that P is going backward with speed of what? Speed of -1. I repeat, -1, velocity of -1. Okay, this I talk about the P particle. Okay, but hold on. this is a smooth plane, so no friction. The friction is zero. You know it very well. So common sense, this will hit. As you know that if a small particle hits the big particle and it will rebound. So naturally, it is a very very clear sense that this 100% will go back. 100% will go back. There's no question about it. Okay, but question comes, if this speed is crossing -1. For example, this q is rebounding after hitting with the r, it will rebound back. If speed is of this q is, let's say, -1.1, 100% q will hit p. But he said there's no collision after that. So my question is, this speed can cross -1? Impossible. If the speed is -1.11, even it will hit the particle. If this speed is -1, even it will not hit. Reason, it is already going and start late there after collision with q with the r, sorry, so that is will not hit. So I will take this velocity -1. Now you can say that, sir, why we can't take less than -1? For example, why we can't take this velocity? I give example, -0.5, -0.1, -0.01. Why not, sir? We can take all these values, but he said find the greatest possible value of the v for this, and that is only possible. When it has a returning velocity is the highest. Okay, returning velocity highest is depending upon this highest velocity. So that is why we can't take this one smaller. Highest possible number for this is depending upon the p velocity. For example, if this is -2, so this must be -2 here. Logic is very clear, but because if they will go back, they must not hit. He said no collision must be there. So that is why I hope so. The point is very clear. And now I'm going to finish the question. So what is the formula? M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So 3 times 2.2, I got 0.6. 0 into 0.5, I get a 0. Okay, negative into that, I get -0.2. V into 0.5, I get 0.5 V. It goes there and becomes 0.8. Or it will divide. When it divides 0.8 by 0.5, and I get finally 1.6 meter per second of velocity of the largest velocity. So I hope so the concept is very clear, and let's go for some extra question practice of today. Okay, so I think, student, this is okay. Alhamdulillah Rabbil Alameen. Now do one thing. Almost what the topic we have discussed, we did not discuss inclined plane questions only. Only inclined plane question left only. Okay, and one more category question left behind. I tell you one thing. I just tell you this question number. Hold on, this one. Look, I show you, students, in my this video, and then I discuss with you what to do. What is the solution of this problem? Okay, so question number 5 is also one of the hard questions. Okay, question is a 5 is also hard question of 8 marks. Okay, so question number 5 and question number 1. Okay, so question number 1 and question number 2 redo. Question number 5 I'm giving. Okay, question number 4 redo. Okay, so this 4 question and one more am I going to add. Hold on. And all these questions I'm going to record in my channel separate. Okay, no need to make a combined in the same video, because basic concept I delivered. Alhamdulillah Rabbil Alameen. Wait a minute, this question number 7 we may be done. Okay, but I want to give inclined question. Okay, this is another inclined plane, question number 8. So I believe question number 8 also. So these questions, question number 8 as well. Okay, so this is first attempting. So these 3 questions I'm going to send in my YouTube channel. You will find all 3 questions there. So that is why. So these 6 questions are your homework, 2 questions redo, and 3 questions new. Please take it, note down, and tomorrow, maximum tomorrow night, you will get these 3 questions uploaded, available in my YouTube channel, and you can first practice yourself, number 1, number 5, number 8, and then you can compare your mistakes from there. And now, all because we spent a lot of time on that question, so I can't proceed anymore. Is enough for today. Inshallah, see you next class. I mean, the topic of linear momentum is over, alhamdulillah. So I believe this much enough, and rest you can take a help from my other videos.